this is the RPS Project. I'm Richard and today I'm going to have a look at the LM386. Got it here on the whiteboard. Basic circuit. It is a very basic, simple 8-pin IC audio device. Very simple, very much like the LM380. Only this is a 386. Not quite sure what the differences are. Except for that the gain has a bit of a different control on it. Pin out there, pin 1 and pin 8 are the gain. Pin 2 is the inverting input, pin 3 is the non-inverted input, pin 4 is ground, pin 5 is output, pin 6 is voltage supply, pin 7 is bypass. Not quite sure what the bypass is for. See it on quite a number of ICs. If anybody knows, put it in the comments please. Let us know what the bypass is actually meant to be used for, because most of the time I just put a capacitor to ground for the bypass. Other than that, I don't really know what I'm meant to be doing with it. Hey, pin 8, 1 and 8 are gain. Simple circuit. It is very simple. Pin 3 to my non-inverted input is just got a pot from my input. Very simple. You see 2's ground, 4's ground, 7's got the bypass capacitor to ground, pin 6 my voltage supply, 5 is my output, which goes to big capacitor over here, and then I've got this little circuit here, these I suppose for a bit of filtering of some sort, I suppose, to keep the output stable. And then over here we've got pins 1 and 8. Now without this you just get a fixed gain. I think that gain's, I can't remember if it's 20 dB or 40 dB, not quite sure, but if I put an electrolytic across there, 10 microfarad, I get 100 dB, I get that more gain from it. You can put pots in there and do it so you can alter the gain to whatever you want, but I'm going to have a look at it first of all without the capacitor, and I'll just put the capacitor on and see what it does. So let's get and have a look at it. I've got it on the workbench, so let's find out what it does. So here we go. I've got it on the breadboard here, my LM386. A few capacitors in here. I'll put a capacitor across the input just to hopefully keep it a bit more stable, you know, for the voltage supply. Pin 7 bypass capacitor. Yeah, well, you know, who knows. Just had a shot here. I've got my got a pot. This is for my input. Big capacitor on the output, and then just here I've got a capacitor and a couple of resistors for that bit of filtering on the output. Now it's I think that's a 1 microfarad capacitor with about 7.5 ohms resistor. I put that in there as two 15 ohms, because all I haven't really got any low value resistors. I've got some low value capacitors, that's for sure, I can tell you. Now where did I draw that diagram? Yeah, I got that. Well, I'll look at that in a moment. But anyway, that's my setup. That's where I've got it on here. It is a basic circuit, so I'm just going to move the camera up till I get the get my scope. There we go. So now I'm looking at the scope, because that's the main thing I want to see. Can I angle that a bit better? Not sure. A bit not the best of stands for this camera, but it does the job, I suppose. Yeah, finally. Anyway, I'm putting into this 500 hertz, 500 millivolts. So got it turned on here. Let's just get the settings the same. So it's 500 millivolts per division, both channels. So let's turn on the amplifier, which I'm using 12 volt supply, and there's my input signal. Quite tiny really, it's a nice little signal. Let's say it's 500 millivolts. So if I now turn up the pot, a bit touchy, like they always are in these sort of metal cased pots. Hey, that's quite nice, comes up quite quickly, and keeps gaining and gaining. Oh, it's a bit touchy. It's probably me just knocking the spaghetti junction about. Wow, that's got a lot of gain. That's so much gain. Wow, I'm going off the might have to rescale the let me just rescale that output on. We're going to 1 volt per division. Remember, that's 500 millivolts input. I can do this without knocking any wires. And just gains and gains and gains. Oh, a lot. And then we've got so much gain, we're actually clipping the top and bottom of the waveform. And I haven't even put in the capacitor that supposedly gives us more gain. So I wonder if I can turn this down input wise. Let me just adjust the 200 millivolts. We'll go to 100 millivolts per division, but I'm going to turn the amplitude down on this. What should we take it to? Let's go for the 100 millivolts. That's a really small signal. So having such a small signal, we should still get a lot of gain from this, but not so much. I'm going to end up. Oh yeah, it gets touchy at that level. Let's turn it up, and wow. Sorry about this, but it's the only way I can do it. I could have to hold on to the pot while I'm doing it. So, and rescale this. I'm on 500 millivolts per division. With that 500 millivolts, I've got 100 millivolts in, and I'm getting out, what's that, 1 2 3 4 5, so that's 500, that's 1, that's 2, 3 volts out, is it? Let's see if I can use the cursor to work and see if I can voltage on channel 2. So just see what this is giving me. About there. According to that, I'm getting 3.2 volts. So it's about 3 volts out. But one thing I'm noticing here is that the negative side is shifted down. We're not getting an even amount of swing above and below the horizontal across that zero axis. It's a greater negative than it is a positive. I wonder if that's some distortion in the bottom there. So yeah, that's slightly off with regards to its positioning, but it is crossing over at the right place. You know, this is giving me what I put in. I'm getting a positive in, positive out. So it doesn't invert it at all. I suppose if I used the inverting input as my input, I could flip it over if I had it the other way around. But I mean, that's basically all I want to do. I mean, I've got a load on there on this rather than a speaker. So, but yeah, that seems to work. Now, what I'm going to do, I can do it without knocking everything about too much. Just turn that down. Input off. Turn that off. And I'm now going to change the resistor that I was saying about, the little resistor for the filtering, and see what that does. I've got two 15 ohm resistors in parallel, so I've got 7.5 ohms. So if I just take, let's just take one of them out and see what that does to my signal. Turn it on, turn on the input, and gently grab hold of the pot and slowly turn it up. Bit twitchy. Ooh, how about that? And if we look at that, I'm getting distortion. So I've increased the resistance and I'm getting more distortion. So if that's working as a filter, and I don't know anything about filters, I've never really done much work on them, so I mean that's something for the future to look at, having a go at filtering. I'm getting some distortion in there at the bottom of the wave as it increases, so it's not as stable, I suppose. Let me change that. I'm going to take out the 15 ohm resistor and I'm going to put in a 100 ohm resistor. I can get it in there. Come on, you bugger. Is that in the right place? I think so. Okay, so now I've got a 100 ohm resistor on that capacitor resistor filtering on the output, and that's not the big resistor. That's what I'm looking at. Not the camera. What I'm looking at here is basically this here. Ignore this bit. This is if you want to put in some bass boost and some control on the gain, but I'm not going to mess about with that really. What I'm looking at the moment is this, to keep it stable. Apparently this seems to have quite a big impact on how stable it is, and I'm just changing the value of that resistor. Seems to me that the smaller the resistor, the better it seems to work. I've just put in a 100 ohm resistor, so let's just, did I turn it off? No, I put it in now, haven't I? Let's see how well this goes now. Ooh, come on, you bugger. Seems to be, oh look, that I'm already getting distortion. Lots of distortion on the negative side of the waveform. Oh, that's really quite unstable now, isn't it? That's I know it doesn't help that I have got spaghetti junction here, but yeah, that's not very stable at all. What if I was to put a smaller capacitor in there? I'm sure that would play havoc with it. So let's grab a capacitor. I've got here a 1 microfarad standard little polyfilm, is it a polyfilm capacitor? I'm going to change that for the little electrolytic, the 1 microfarad electrolytic that I've got in there. If I can get it in there. Get in, you bugger. There we go. And I'm expecting this to be quite dramatic because well, not really. I mean, that's a 1 microfarad and so is the one I've just put in there. Only it's a different type, it's not an electrolytic. So let's turn this on. There's my input, and by rights it shouldn't have too much of an effect. Oh, look at that. It does that. Look at the amount of distortion there is in there, and that's, I think the main thing is the resistance. So I'm just going to pull that resistor out, go back to the electrolytic, might as well. I'm putting these 10 these two 15 ohm resistors back in there. Because it seemed to work best with the two 15 ohm, well 7.5 ohms in it, because they're in parallel. It's always so fiddly on a breadboard trying to get stuff in and out and get the capacitor in the correct way. From the output, pin 5. Right, okay. Circuit back on, input back on, and there you go. If you think about it, it's not, I'm getting some distortion, but it doesn't happen until I'm like right on full gain. So there you go. I mean, that works perfectly fine. Don't have a problem with that at all. I mean, seems really quite a nice stable output. Now if I take my 10 microfarad electrolytic and put this across the pins 1 and 8, I supposedly should get a lot more gain, but I'm wondering how stable it's going to be, because you know at this, with the fixed gain that I've got on it at the moment, I can get it to be fairly stable, but I'm imagining that if I put a lot more gain into it, it ain't going to be so stable. Pin 1's got to be the positive side of that electrolytic, so pin 8's the negative, so I put that in, I've got that in my circuit, turn it on, there we go. Input's fine, so let's turn up this pot and see what happens to it. Oh yeah, ooh, gets to about there, which is about the normal gain that I would normally have without that capacitor. And as soon as I go above it, wow, yes, I get lots of gain, but it's massively unstable. So let's just change the something like 2 volts per division now for the output. Look at that, it's just, as soon as I try to get in, basically it's just getting clipped, and it's not steady neither, because we're just running into the upper limits of the voltage supply, which I've got 12 volts for this, so yeah, it doesn't look nice at all, does it? So let's turn that back down. So yeah, I suppose you could, if you wanted a signal that was massively overdriven, that was going to give you a sort of nice clipping and noise and all the other rubbish that you get with overdoing the gain, shove the capacitor in. It'll do the works. If you want it nice and clean, I'd expect that actually you want to leave that capacitor off. And what have I done to it? Oh yeah, I've changed the 2 volts per division, haven't I? So I've changed the scaling. So let's turn that back to 500 millivolts, which is what I had it on. You've got 100 millivolts per division on the input and 500 millivolts per division on the output. So like I said, from 100 millivolts input, I'm getting about 3 volts output, which to me is perfectly acceptable for driving a small speaker. I think that's a winner. I like that. It works quite nicely without having to put in the extra gain capacitor. If you don't need it, don't bother with it. Brilliant. So there you go, the LM386, a very simple audio IC, works really well, don't need very many components with it. You can actually use it for other things. That's a data sheet. I don't know what I've done with Notepad, got a data sheet somewhere, but I'm sure I'll find it in a bit. Anyway, You can use this IC for doing slightly other circuits I've seen on the data sheet, not just as a basic audio output into a speaker. Get a full range speaker, you know, what more can I say? It works really well. There is one thing though that I noticed about it, was the gain. Controlling that gain is a bit, well, I don't know, takes a bit of a touch, doesn't it? I mean, you can get quite a nice gain as long as you've got that output right, like I was saying before. Let's have a look on it. This part here, this resistor and capacitor, even though it looks like it's fairly innocuous, what do I need that for? Actually getting that right helps keep it stable, because without put my teeth back in, without that capacitor and resistor being in there and getting the right values for it, this thing tends to get a bit glitchy. It tends to have a lot of noise, I suppose, oscillation feeding back into the IC and giving you a really noisy output. So keeping that output clean is really quite important. And of course, on this diagram I've also put on there for a pot and that for the bass, because you can alter the bass and get a bit more bass out of it, and then obviously there's the capacitor for getting a lot more gain out of it. But even without the additional capacitor across pins 1 and 8, it gives a lot of gain on there. So unless you really want to overdrive this IC, then I can't see that really you need that capacitor, unless, like I say, you really feel you need it. But there you go, the LM386, nice basic simple audio IC, worked really well. I like it. Anyway, if you didn't like this video, you know what to do. If you did, give me a thumbs up, subscribe, and all comments are welcome. See you next time.